We're here at the example table, and in this video we're going to introduce the idea of vertical asymptotes. This is something that you'll talk about more in a calculus class, but we can introduce the idea here. And let's do so by example. So let's graph the function f of x equals 1 over x. To do this, we can start by anchoring 2 points. If we plug in 1 for x, we get out 1. And if we plug in -1, then we get out -1. So this graph is going to pass through 1, 1, and -1, -1. If we set x to be some really large number, then we know that 1 over that is going to be a very small number. So as x increases, this graph is going to decrease down to 0. The details of that belong in a different video. Our concern here is what happens between 0 and 1. So for example, what is f of 1/2? Well, 1/2 goes in the denominator. When we take 1 over that, it flips up to the numerator and becomes a 2. So f of 1/2 is 2. Similarly, f of 1/3, a smaller number, right, closer to 0, is 3. f of 1/4 is 4, and so on. So f in general of 1 over any number is just that number in the denominator. Even more generally, if we can't represent it as a fraction, it doesn't matter. If x is very small, 1 over x is going to be very large. This means that the graph, as we get closer and closer to 0, is going up toward infinity. Now, similarly on this side, if x is going off in this direction, then it's going to get closer and closer to 0. Again, that's a topic for a different video. But if x is, say, -1/2, then 1 over x is -2, -1/3 becomes -3, -1/4 becomes -4. So on this side, we see that we're approaching -infinity. This line, which in this case is the y-axis, is what we call a vertical asymptote. So let's give that a slightly more formal definition. And actually, I say slightly more formal, but it's still informal. And this is something that can be made more formal in the context of calculus. So, a vertical asymptote of y equals f of x is a line x equals h, so x equals a constant, remember that's a vertical line, such that f of x approaches plus or minus infinity as x approaches h. This is something that makes it informal. This notion of approaching, this is what will become clearer in a calculus class. But for us, we can just think of x getting closer and closer to h and f going off to positive infinity or perhaps negative infinity. In the context of this video, our focus here is on rational functions, but vertical asymptotes can exist for other functions as well. Let's look at another example. Let's say we have y equals 1 over, not x this time, but x squared. So here, we can anchor 2 points again. So if we plug in plus or -1, the output is 1. So this graph will pass through 1, 1 and -1, 1. Similarly to the other function, as x increases, right, if x is 100, then y is going to be decreasing. Y is going to be small for x equals 100. So the graph looks something like this. And as x gets closer and closer to 0, but is never equal to 0, this is getting larger and larger. Right? Note that this isn't defined at 0. The difference between this and 1 over x is that on this side now, all the values are positive. So this is actually a mirror image. Now, this looks like almost exactly what I drew for the previous example, 1 over x, for these positive values. It's not quite the same. It would be worth figuring out the way in which they're different. Let's do one more example. Let's let y equal 3 over x minus 4 cubed. Let's see. So we'll talk about this more in the next video. We can sort of intuit that the problem point here is going to be x equals 4. Right? It was x equals 0 for those last two examples because we couldn't plug in 0. Here we can't plug in 4 because that's what makes the denominator 0. So we are in fact going to have a vertical asymptote at x equals 4. Now, what happens for x larger than 4? Then this is going to be larger than 4. X minus 4 is going to be positive, small but positive. So the curve is going to look, let's stay consistent with this. The curve will look something like this. What's going to happen if x is on this side of the dashed line? Then x is going to be slightly less than 4, making x minus 4 slightly negative. Something slightly negative to the third power is still negative. So we're going to end up with something that looks like this. And if you wanted to, we could figure out what this point of intersection is with the y-axis by seeing what this evaluates to when we plug in x equals 0.